Hello, everyone. My name is Andrew Nee from AI in the Liberal Arts, and today I'm going to tell you a bit about how AI can help with qualitative research. With all the recent hype around large language models like ChatGPT, including a lot of skepticism about is this reliable at all? Is this going to take people's jobs? Is low quality AI content going to flood the internet? I thought it'd be nice to take this opportunity and highlight some slightly older and less exciting, but more well-accepted, well-tested AI and general CS techniques just to help people who might not be very familiar with computer science already. This is going to be somewhat of an interleaved presentation and demo, and I will basically go over a concept and some practical tools, and then see one of those tools in action in a running example. So we're specifically focusing on AI for qualitative science, but what does qualitative science even mean? This is a field that deals with qualitative data, basically anything that isn't numbers. Common data sets might include interview transcripts or recordings, social media posts, long-form texts like books and articles, art pieces, and musical tracks. Qualitative science basically aims to draw qualitative conclusions from large amounts of this non-numerical data. For example, a UX researcher might want to analyze user reviews on their website, distill out a couple common trends among the poor reviews, and then use that information to determine basically what do we need to prioritize next to improve our website. Or someone conducting a research study of first-generation immigrant experiences might want to automatically extract some information from each interview, like a summary of the interview, the overall attitude of the response, or information about their body language and tone, so that when they come back to the interview later, when they might have forgotten a bit about it, to do analysis, this is going to help them speed up the analysis process. Finally, a business might want to get a better grasp on their target market before committing to a large investment. So for example, someone that's trying to make a fine-tuned LLM might want to analyze online trends, commonly bantered phrases, and overall sentiment in relation to new LLM products before investing big. The idea of this presentation is to present a couple of AI tools and techniques to help with analyzing large amounts of qualitative data, as well as more traditional CS tools. To be more useful to people in these qualitative disciplines who may not be very familiar with coding, I will try to make this as code-free as possible. And this presentation is loosely structured around a tutorial paper, which can be found at the bottom here. Now, the basic process of data analysis, both qualitative and quantitative, can be broken down into 3 steps: obtaining the data, exploring the data, and analyzing the data. One of the most common methods for obtaining qualitative data is web scraping, which includes things like social media scraping. Other methods include database searching and actually going out and collecting the data yourself, such as in interviews or surveys. The main point of the next step, data exploration, is to get a better understanding of what your data set is, and uncover any potentially important findings that you may not have expected going into the research. So even if you're like doing a thesis and you have a predetermined goal of, I want to take this data and perform this analysis to see if it supports or disproves this conclusion, it's still a good idea to perform some exploratory analysis, just to make sure that the data looks the way you expect it to, and to identify any obvious anomalies or trends that might make you go back and reevaluate how you got the data in the first place. Finally, once we verify that the data looks okay, and we now want to use that data to support some conclusion, either a conclusion that we came into the research with or that we discovered from the data exploration, now we're in the data analysis step. To be honest, this step is not always distinct from the data exploration step, since in many cases, figures and visualizations are going to speak much more effectively to people than statistics and words. Some techniques in qualitative data analysis include sentiment analysis, where we categorize texts based on how positive or negative they are, document summarization, where we take a long segment of text and try to distill out the essential information, and entity relation modeling, where we first try to identify entities from a text, for example, characters in a book, and then we try to extract the relationships between these entities, such as James is Mary's brother. For our case study, we are going to analyze tweets about the TikTok ban, a pretty recent and controversial topic. We're going to go through the 3 steps mentioned before, obtaining our data through web scraping, visualizing our data set, using a word cloud, and then doing some sentiment analysis to draw some conclusions about our data. The idea of this case study is basically just to tie all these concepts together in a more real world-like use case so they're not presented in isolation, and to help people better understand the kinds of things that these AI and CS tools can be used for. So now let's go over each of these steps, these 3 steps in more detail and look at how they might be used to analyze tweets about the TikTok ban. For each step, we're going to go over what it is and how to do it, and then describe and illustrate a couple of tools to use for that step, of course, using as little code as possible. And then we will see how we can apply one of the tools to our case study here. So like we mentioned before, web scraping is extracting online information from websites. Traditionally, it's done by writing programs and interfacing with the API, that's the application programming interface of websites. This is the most powerful and flexible way to scrape the web, as all other methods are basically just graphical interfaces built on top of this. However, it can be very tedious to code the program, and you kind of run the risk of being like this comic on the right, and it's not accessible to people who don't know how to code, which is a big downside. So this is why companies have developed, and people, graphical interfaces and plugins for scraping the web. We're going to show a couple of Google Chrome and Google Sheets add-ons that will help us access a bunch of data, more than we would really want to process manually, but with the same ease and familiarity as simply visiting a website. The downside, of course, is that these apps can take more time to extract the data than a handwritten program. They might ask you to pay for their services, whether all of their services or just a premium subset, and they might not be maintained super well, leading to crashes and sometimes not being available. We're going to go over 4 web scraping tools here: ParseHub, Twitter Archiver, Bardeen, and Wikidata scraping. Of the tools we're going over today, ParseHub is the most similar to what a programmer would have to do to code a web scraper. So websites, if you didn't know already, the content in web pages is grouped into different HTML tags for formatting into paragraphs or tables or headers and organizing into different blocks. In addition, websites will assign various CSS classes to different HTML tags to control the style of what's inside, things like text color, font, size, etc. A lot of web scrapers will try to exploit this system to extract the information that they want, based on rules of, I want the information in this HTML tag with this class. But the issue here is, how do we know where our information is? How do we know what tags and classes we have to put together to get our information? So in practice, what we generally have to do is go to the website, use inspect, and try to piece together a couple of useful rules that we can then use to extract what we want. So for example, let's say I want to extract all the remote controls prices from Amazon and find whichever one's the cheapest. I would right click on a price and click inspect, and it would take me to this screen on the right. Nicely highlighted, we see that the $12 is in a span tag with an A price whole class. Going down, we see that the 99 cents is in another span tag with an A price fraction text class. So if we wanted to get the price, we would have to scrape for the all spans with a class of A price whole, and then all spans with a class of A price fraction, and then put them together, which is pretty tedious. Luckily, in this case, the Amazon designers have anticipated that, and there's this invisible off-screen span with the entire price contained in it. So what ParseHub does is it basically like automates this, puts this into a graphical interface so that all you have to do is visit a website, point and click at what you want, and then it will fetch that information for you. To use ParseHub, Simply go to the website. You can download it for free, and then you can open it up. Where did my parcel go? You can open it up. There's a bunch of tutorials that you can use to learn. I'm just going to show you my project here. Okay, let's start from scratch. You basically give ParseHub the URL of the website you want to scrape, and then it will take you here. Let's select the price, and then we just click on the price. And now down here, we're shown a preview of the information we're going to extract. We see that there's this URL that we don't want, so we're going to expand and get rid of the URL. And we see that there's only one price selected right now. That's because ParseHub tries to guess what we want. It doesn't know if we only want the first price or whatever, so we have to then select more prices to tell us, yes, we want all of the prices. But luckily, it does highlight these things that it thinks we want in yellow. So we can go ahead and select this $189. We see that we have 6 items now, which is more than before, but not all of them. So we go and select this $9, and we basically have all the items. And then we can see them in this preview here. And then we can see that here on the left, for programmers, this is basically the rules that we use to get this information. You don't need to really know about this if you're not a programmer. And then we can get the data. But let's say you did not already know that you could select the thing behind the 12 to get all the information. Let's say you naively click on this to get the 12. Don't worry, let's get rid of the URL first. You can still click on this 99 to get the price fraction. And then you can see that they're going to be side by side, and we can extract them into a CSV to process with Excel later. Once we click Get Data, we can run the project on their servers. It's going to take quite a while, so I've done that beforehand. And we have our run results here. Let's get rid of the strange dollar sign, the dollar signs, and all of the new lines. Fun. There we go. And then, by the way, for new line, you just type Option Enter on a Mac. Price. Let's get the value of this text here. Crap. This text. And then let's find the minimum price, which is 5.5 right here. Okay. Obviously, this example doesn't illustrate the entire suite of available features, but it's free to download. You can just download it and look at all the tutorials to see all of what it can do. The next tool here is a free Google Sheets add-on called Twitter Archiver. You can use it to search for tweets using phrases or hashtags, and it will automatically extract the search results to Google Sheets. You'll need a Twitter account, obviously, but you can just make a burner account. To use this, search for the Twitter Archiver, go to Google Marketplace, you can just add it, and then once you have a sheet, sorry, this is spoilers, but we're doing it later, you can go to the extensions and activate it. Unfortunately, as you can see, it's temporarily unavailable due to changes in the Twitter API. So although we would like to use this, we have to look for something else. So this is one of the drawbacks of using third-party software, is that it might not always be available. But luckily, I was able to find another app called Bardeen.ai. This is a free Google Chrome extension allowing you to integrate many different websites together. We are going to use it to scrape tweets from Twitter into a Google Sheet, but it can also link many different websites together into automated tasks, shuttling information from one app to the next until you get the end product you want. So for example, one automation could extract information from Google News into Google Sheets and then summarize the news articles using ChatGPT. And then an editor could come in for proofreading and then send the TLDR to an automated mailing list obtained by scraping all of the employee emails off of their company website. But we're not going to do anything that complicated. To get Bardeen, simply visit the website. You can get started. Just install the Google Chrome extension, and then you will be able to access it from any tab. It will pop up here. Since we are kind of new to the process and don't know this very well, we're going to ask it to scrape tweets to Google Sheets and let them generate an automation for us. Takes a little while. Oops. Scrape a Twitter search. Okay. So as we can see, this middle block here is premium. Even though we have premium from our 14-day automatic free trial, this is not going to be accessible to everyone always. So let's get rid of this. We can do a little workaround. Oh, sorry, we have to edit first. We can do a workaround. This says scrape did it in the background. This is a premium tool, but we can delete it. Delete this. And we can instead scrape from an active tab. We can use, which is free. We can use the Bardeen Twitter homepage thread search and feed template. We can scrape 100 items and then be done. And then we have to attach the output to this Google Sheets. Come on. Oh, we have to delete that first and then attach this here. And that's our automation. We can be done. I've already made this automation. Well, this automation here. So we can just use that. Then when you, the downside of this, of course, is that since it's not in the background, you have to actually go to the website. How do I move this? Oh man. Okay, we have to go to Twitter, search up TikTok ban, and then open Bardeen, run this, new sheet, and then we can run. Unfortunately, I have actually already used up all of my credits, my free credits for Bardeen.ai. So that illustrates another disadvantage of using this commercial software, is that you can't do everything you want. Okay. But luckily I have, I used up all the credits to do this basically. So I have all the information here. And we can just skip that step. All right. Our last web scraping tool is a Google Sheets add-on that lets us use Wikipedia from Google Sheets. We can grab the Wikipedia description, translations, synonyms, all these different things just using Google Sheets functions. So now let's apply this to our um, TikTok ban, TikTok ban dataset. Okay, we can go to extensions, open up this documentation. It appears on the right. We want the data descriptions. So it's gonna autofill for us. Wikidata descriptions returns the descriptions for a Wikidata item. We need the ID, so we're gonna get the QID, and then we're gonna use this weird format to get the page according to this person's name. It's gonna go like that. If there is no page, this is gonna be blank. It's also gonna take a little bit of time. So I've already done everything here. So let's look and see if we can find anything interesting. These are just disambiguation pages. That's a family name, yada yada. The more interesting things are at the bottom. There's an American journalist, Jessica Lessin, a Chinese American politician, Solomon Yue, a major daily newspaper. They're reading, they're saying these things, and we can analyze. If we had more data, we could extract all of the important political figures and then analyze what they're saying as opposed to what us commoners are saying. But we only have 100 or so tweets, so the sample size is not big. So data visualization is a field of computer science concerned about the visual presentation of data for consumption by humans. So now we're in the data exploration step here after we've collected our data. Even now, there's active research on what the best way is to visualize and explore difficult data sets, such as high-dimensional or multimodal data sets. Usually, data visualization is more concerned with visualizing large sets of numerical or textual data, but there are also methods for visualizing image data sets using methods like TSNE. Some common ways to visualize free-form text datasets include word clouds and network graphs. So this is a word cloud here. It's an artistic grouping of words where the size of each word or phrase corresponds to its frequency in the dataset. Network graphs show the connectedness between entries in a dataset and can be used to show things like what double majors are the most common or which characters in a book interact more often. And you've probably seen some of these in college admissions before. And then obviously charts and heat maps can be used to visualize one or two-dimensional data respectively. Beyond that, many data visualization techniques are concerned with condensing super high dimensional data. For example, all the pixels in an image into a couple of summary dimensions that capture most aspects of the data set, but can actually be plotted for humans to see. So that's what TSNE is. So finally, data visualization is very big in the business world as an intermediate between the people working with and collecting the data and the people who need to make the big calls. So companies have developed specialized commercial business intelligence software such as Tableau or Power BI, but those are paid. So to support qualitative scientists using big data tools, the authors of the paper have created a Python application called Fighting Without Fighting. The reason it's called that is because it was originally intended to be a no-code way to get the benefits of coding to conduct data analysis. But the web app is no longer up, so we will have to do this the hard way, involving a bunch of strange CS paraphernalia, but I will try to keep the jargon to a minimum. So to get started, we have to navigate to their GitHub page. We check the license, see that we can actually use it, and then we can download their repository, which basically gives us their code. Now we have this. We can open up our terminal, which for me is right here. And then we can use different commands to navigate around. CD means change directory. Dot dot means go up. Now we're in the downloads. As you remember, this master folder was in our downloads folder. So then we can go to FWF master. Okay. And now we see ls means list all of the entries in a directory. You can see fighting without fighting is right here. Now, before we actually run it, also, I only know these because I use them all the time, and there's no shame at all in looking things up if you don't know what's going on. Now, before we actually run this package, it actually relies on a couple of other packages, which is basically software that people elsewhere are developing that we don't want to, code ourselves. So we just use their code. The best way of doing this is using virtual environments, which is basically little containers that hold all of the installed packages so that they don't conflict around with each other. It's kind of like organizing the stuff in your room into boxes or shelves. So if you want to do that, you can go to Anaconda, free download, and then you will be able to run commands starting with Conda. But I will also go over how to go about this for people who don't want to use Conda. So if you have Conda installed, you can do Conda create name FWF. I already made one to test it. This just tells Conda to create a new box with the name FWF to hold all of our installed packages. Now we have to activate our new environment to tell Conda this is what we're going to use. We're going to use stuff from this box right now. We have to install the packages. Python, we want Python to be able to run the script. Python pandas matplotlib cborn word cloud. Don't worry about all these names. They're just the names of stuff that are used in this software. Yeah, again, I'm really sorry that the web app is down. And this will take a long time, so I'm skipping it now. And then you would type pip install scikit post hawks, which are going to be used for statistical analysis later. Run that. They will ask you to confirm. You can just press Y. But this takes a long time, so we're not going to do it. I've already installed the relevant packages, so we can just do Python fighting without fighting. Oops. Wrong name. We can run it with Python, and then it'll take a while, and then a graphical user interface will pop up. Like this. Okay. Now we have to download this as a CSV. TikTok ban sheet 2. We can load it into here. Click tags cloud. And we want to generate a word cloud using the body of all of the posts. So now we do this. And that's a word cloud. Okay. Hope that was I think by far the most like coding part of any of this presentation. So if you got through that, like great job. It's all downhill from here. All right, so now we can look at this word cloud and we can see a couple of things. Obviously, TikTok ban are the most often repeated words since it's the topic we're interested in. But looking a bit more closely, there's a lot of talk about governments, representatives, Biden, American government, stuff like that. and also information about, also phrases and concerns about other countries like China, Gaza, about privacy, um, uh, free speech right there. Um, there was another privacy one. I can't see it right now. Um, and free speech. Oh, censorship. There's a censorship somewhere. Censorship right there. Okay, so now that we've established that our tweets behave um, approximately the way we expected, and there weren't any, super common, super large, unreasonable words that would have made us reconsider our data scraping approach. Now it's time to do some sentiment analysis. Sentiment analysis is basically extracting subjective information from text, such as the connotation of words, whether a statement is positive, negative, or neutral. For example, group, clique, club, and gang are basically the same thing, but to us, they have slightly different meanings, and sentiment analysis could extract those subtle nuances. In addition, we can also categorize statements by their emotions, such as anger, fear, disgust, and the strength of those emotions. And finally, we can describe how objective or subjective statements are. For sentiment analysis, we can use Meaning Cloud, a free Google Sheets add-on. This has the advantage of easy analysis. And with just a couple of clicks, you can do topic extraction, text classification, and clustering, in addition to the sentiment analysis that we're going to do. However, the drawback is that the free tier is very limited. I've already used all of my credits for this just to do the text processing, text sentiment analysis here. So if you want to do a lot of it, I would suggest either learning to code and using an R or Python package. You could ask the school to help you buy the premium plan, or you could find some other tool. We're going to use sentiment analysis here. Basically, you go to extensions, Meaning Cloud, analyze sentiment, and then you select all of this to analyze. What happens is you get this, these results with the text, the polarity of the text, whether this is agreeing or disagreeing, the subjectivity, how confident Meaning Cloud is in its assessment, and whether it's ironic or not. So now we can do a bit of basic analysis. We can count the number of texts with each polarity using this function COUNTIF. We see that there are very slightly more positive tweets than negative tweets, but that most of them are uncategorized. You can count the subjectivity versus objectivity. Most of these are just statements without really opinions. Meaning Cloud is pretty confident in its results. And there are no ironic tweets here. All right, now let's look at how the number of views differs between tweets of different sentiments and try and see if there's clickbaity, super negative political commentary on this topic. Unfortunately, our scraped text is pretty dirty. You can see here, some of these are numbers, some of these are texts like 3M and 2K. So what we're going to do is use a Google Sheets formula. Hopefully I have it here somewhere. All right, I seem to have misplaced that, so I had to recreate it off screen. Here we have the views numeric column and this big long formula. Basically, this says if search looks for K in this cell, and if it finds K, it will return the position of K, and if it doesn't, it returns a value error. So is number search basically says, is there a K in this cell? So if there is a K, that means it's a some number of thousands. So we take away the K and we multiply by 1,000. If there's no K, maybe there's an M for million. So we do the same thing for million with M and 1 million. And if neither K nor M is present, then it's just a normal number. So we just keep it as it is. So now here we have this column of all the views converted to numbers. We can download this as a CSV, sheet 3. And then we can do fighting without fighting again. Go back to our application. You can just press up to run the previous command. Load our file. Sentiment analysis. Oh, oops. Let's copy the polarity column. I forgot to do that into this sheet. And then download it. Sorry about that. Loading the file. Okay, so now we have our polarity column. X-axis is polarity. Y-axis is number of views. We're going to do a strip plot. And I'm going to visualize. Okay. First thing that stands out, most of these points are at the bottom because of two big outliers in the none category. So let's look at what those are. Obviously, this is one of them. It's just a really viral tweet with that meaning cloud doesn't know what the sentiment is. So let's get rid of these to get a better look at the rest of the points. There's another one with 700K. It's very similar. Just a funny comment. Oh, that's not a funny comment. This is a political comment. But meaning cloud does not know the sentiment of this, unfortunately. Okay, now that we've gotten rid of the two viral outliers, let's re-download this. It's waiting for Wikipedia tools. Okay. It's done. Didn't run fighting without fighting. Now we can look at the polarity again versus the views in a strip plot. And now we can see a much more clear picture, keeping in mind that there are two big outliers up above here in the none category. So what we can see here is basically positive tweets tend to generally get a bit more attention than negative tweets, but when negative tweets go viral, they get more viral than positive tweets. There are also tweets that Meaning Cloud doesn't know how to classify, but we cannot really use them for our analysis here. But because our data set is so small, this is not a significant discovery. As we can see by clicking statistical analysis, there are no significant differences between the groups. So to do more in-depth analysis, we'd probably have to code our own web scraper or wait until Twitter Archiver is ready again. Okay. Sorry about the technical difficulties. So that was it. We went over some AI and CS techniques that could help qualitative researchers obtain and process large amounts of data. We discussed some free tools that can be used throughout the whole process. And even though we weren't able to draw any conclusions from our limited data, we showcased how some of these tools can be used in a real-world application. Now, here are some honorable mentions, which are great software used by professionals, and they're only honorable mentions because they're commercial and you probably need funding to use them. Atlas.ti and MaxQDA are pretty much the state of the art in terms of qualitative data analysis, offering features like the ability to chat with your documents, basically have ChatGPT like read your document and then create a persona embodying that you can talk with. As well as more traditional techniques like extracting opinions from interviews, various data visualization techniques, and other features. Also, as we saw with Bardeen, a lot of these data processing applications are adopting a kind of AI inception, where instead of using ChatGPT for all of their data analysis, they use it instead to help users get more familiar with their interface, use it to suggest data pipelines for the user that they can then edit to simplify the user experience. But the actual data analysis and visualization is done using more well-established and more trusted AI methods. So like I mentioned before, this presentation was loosely based on this tutorial paper, the first citation. And if you want to explore further reading, you can look at some of these papers down here as well. Thank you for your attention.